Okay, all yours.
Okay, so welcome everybody. First of all, thank you for attending this talk. Today I'm going to talk about two technologies. They have the potential to change the web as we know it today. Two technologies of increasing popularity in recent times. As you can imagine, I'm talking about Rust and WebAssembly. Say that I would like to split this talk into two parts, and we're going to start with Rust. Okay, so Rust is a programming language created by the Mozilla Foundation. And what it means there is no evil corporation behind it, like Microsoft, Oracle, SAP. It is a foundation which provides an open community where you can collaborate with if you wish. So Rust is a low-level language. It would be in the same category with languages such as C or C++. And one of the best things that it has is performance. So technically, Rust is considered a system language because in Rust, there is no garbage collector, okay? So garbage collector is the mechanism in charge of managing resources, freeing up memory. And what it does is reduce the margin of human error managing machine resources. But on the other hand, it introduces an overhead in performance issues, okay? But don't panic, we don't have to worry about it. We don't have to think about pointers and those things, okay? So now I want to show you this graph. As you can see, on one hand, we have languages, system languages, such as C and C++. They don't have garbage collector. They have a very high level of control over resources, and at the same time, a high level of performance. And the other extreme, we have languages that implement garbage collector. Therefore, they are considered more secure languages, okay? So now the question is, where should Rust be here? That's one of the Rust greatnesses, because practically Rust would be in both sides, okay? So Rust is a language that, as I said before, it's going to have a high control. We're going to have a high performance, and at the same time, we're going to have ultra secure code. So Rust currently is considered one of the safest language, because in Rust, some type of bug, such as null pointer, reference errors, in Rust they cannot exist. They're technically impossible. No bug, right? So we have the best of both worlds. We have performance and we have security as well. So where is the magic behind that? So the real reason is his ownership. But about the ownership, I'm going to talk in a while, because now I want to show you a little more about Rust. So let's start with the basics. So Rust is a multiparty language, and what it means that we're going to be able to do object-oriented programming, we're going to be able to do a functional programming, and we are going to do imperative programming. What I mean is, Rust was not born as a language, for example, purely object-oriented, like Java, C#. It adapts to multi-system programming styles. In the end, Rust, like any programming language, has a trunk part, it has variables, loops, and all the basics that all programming languages have. So let's start with the variables. So in Rust, logically, there are constants, there are variables, and as you can see here, the variables in Rust are defined with the word let, just like we do in JavaScript. As we can see, we can define a variable without value, but if we try to show it value, we're going to receive an error. Why? Because unlike JavaScript, in Rust, there are no new value. It is a good thing because we will never check if that value is null, as we usually do in JavaScript. Another thing to keep in mind, as we see in the variable 2, we are assigning a value 5. Then, if we try to change that value, we will also receive an error. Why? Because in Rust, by default, all variables are immutable. This is another point in favor, because we're not going to deal with the problem that we have in JavaScript. For example, changing the variable value multiple times, for example. So now the question is, can we change the value of a variable? Of course we can. The only thing that we have to do is indicate that this variable is mutable. In order to do that, we indicate with the prefix mat before the variable name, and with that, we could already modify the value of a variable. Okay, so Rust is a strongly typed language. So we can find any type of value, like a string, integer, array. Then in Rust, the types number is also very large. We can have integers of 32 bits, 64 bits, negative integers, positive integers, and these for Rust are different types. If we have TypeScript experience, we will probably be familiar with these types. So if we only have experience in dynamically type languages, like JavaScript, this can be complicated for us. But in summary, it's a guarantee to later avoid some problems in the future, okay? So what about functions? In Rust, the function don't have any special magic. They are similar to the function that we have in JavaScript. They are defined with the prefix fn, name of the function, and then in brackets, we indicate the arguments and the corresponding type of the arguments. In this example, we have a function that calculates the square of a number, and this receives as a parameter a number, a 32-bit integer, and returns its square, which is logically also a 32-bit integer. So in Rust statements, as in JavaScript, end with a semicolon. And inside the function, there is also a return. But if we don't indicate the semicolon at the end, we can do exactly the same as we do with the arrow function in JavaScript and avoid the return. This is up to you, just to keep the syntax. So, well, we commented that Rust is a multi-paradigm language. From my point of view, the object programming of Rust, I love it, because it's not like the classic one with classes, inference, interfaces, and all those things. I think this kind of software development is already over, and Rust object orientation goes a little bit along that line, okay? It's very pragmatic, very simple. So let's see how it works. So where is a struct? Struct is an acronym from structure, and this is something as simple as an object in JavaScript. We have here, for example, define a struct for a rectangle, and what we do here is indicate the property that we want to give it, as well as the corresponding types, okay? Finally, we have a rectangle object or struct with a width and height of 32 bits. A curiosity to see here, in Rust, we don't use constructor. The word new is not a reserved word, and it's happening in more cases, okay? So how do we get the instance of that struct? So basically, we get it with the instance name, in this case, rectangle equal struct name, and the values we want in the struct property, okay? So how do we access these properties? In the same way that we are used to, instance name dot property name. So like all object programming, struct also support method, but this is done in a different way that from what we know. Now we will see. So as we see here, in the struct, we cannot define a method. The struct is only the definition of the property that it has. And then there is a separate block where the methods are implemented. This is the block that we see here below, implementation, okay? So on the one hand, we have the struct, and the other, the implementation of the struct method. I particularly like it because it's really clean. It is an interesting separation of concept. In Rust, we are not going to see those long classes of 1,000 lines with many gets and sets. So inside the implementation block, what we do is define the current function. As you can see, we have defined a function called getArea, and it returns the multiplication of the two properties of the struct. So another thing to analyze here, in Rust, there is no this. Instead of that, we use self, and as you can see in the example, okay? Well, and how do we execute the method that we have implemented? Basically, in the same way that we do in JavaScript, instance name dot name. Functional programming. Okay, another important feature that I want to share with you is functional programming using Rust. So as we work daily with JavaScript, are used to use filter, map, reduce. This is because it provides us a very nice syntax, okay? Unlike JavaScript, the catalog of this type of function is more extensive. Why? Because the amplitude of the language it's greeted. So here we have a very simple example. We have a vector, an array with integers, and through the functions, we can do really amazing things. Basically, with the into the method, we move inside the vector. For example, take the first 4 elements of the vector. Filter works the same as in JavaScript. We give a condition to filter. In this case, it checks the even numbers. And with count, we count how many elements have reached the end, okay? In this case, 2. These are very simple examples. There are many. In Rust, for example, 2 arrays can be merged. You can apply for a map. Many things we can do. Okay, so another feature that Rust has, and it's also shared with JavaScript, is the presence of the iterator. It's actually something that has recently arrived in JavaScript, and surely in Rust it has greater way that it does in JavaScript. In JavaScript we have the iterator, we use them, but we can more or less survive without them. In Rust it is complicated. As you know, the iterator implements the iterator pattern. It allows us to iterate data structure without exposing that same data, okay? So normally, we have the next method that every time we call it, we get the next value in the right. Here we have a vector, then thanks to the ither method, we convert that vector into an iterator. Then from there, we can call the next method to obtain the next value. In Rust, there are obviously a lot of loops, for loops, while loops, etc. Here we have an example of the for in loop. This is similar to the for in JavaScript. Okay. Okay. I don't know if you remember, but at the beginning of the talk, we talked about Rust being a language that doesn't have a garbage collector, but it has the best of both worlds. We have very high level of control, excellent performance, and at the same time, a good level of security. So what is the magic behind that? So it is the ownership, okay? This is the main feature of this language. There is no other language that applies it. At least I don't know. So understanding ownership is a fundamental requirement to programming Rust, because ownership is like the only ring. It governs absolutely everything in language. In this way, if we are not able to understand it, it will be difficult for us to do anything in Rust, beyond basic example for sure. I'm going to try to explain it in a very simple way with a couple of examples, okay? So, well, in Rust, there are types such as string, that when we assign them to a variable, instead of copy its value, in reality what we are doing, it's moving, okay? There is a basic rule from the ownership that a value can only have a single owner at the same time. So what's happened? Here we have a string, Lenny is the real Mati, and right below we are assigning string 1 to string 2. When we do that, in most programming language, we are copying the value, right? But not in Rust. In Rust, what we are doing is moving its value, okay? I'm saying to the compile, hey, now the owner of the string Lenny is the real Mati is no longer string 1, it is a string 2. So what does the compile do? Well, string 1 makes no sense anymore, so I remove it. So if we try to access that variable, we will see that it doesn't exist anymore, okay? This is also applied to function, and if we see below, we have the same string and also a function that we could call it take ownership, which basically does is return the same string that it receives, okay? So we pass a string 1 parameter to the take ownership function, and then later we're trying to access string 1. So we will receive exactly the same error. Why? Because we have moved string 1 to the value parameter. So what's that? In Rust, we cannot have a value passing to a function and then continue having that value. There is actually one way to do that. It is using reference. We have to add an ampersand before the string parameter. I have decided not to show this because it's going to be longer, the talk. And I just wanted to give you a small overview of Rust. But then if you are interested, we can do another talk and see a little more about the ownership of Rust, okay? So now let's move to the other technology, which is WebAssembly. So people like to say that it is the future of the web. I like it, but there is another one that I like more, the democratizer of the web. And if we think about it, it makes sense, because if we want to write an API, I can choose any programming language. No, I can write it with Rust, with C#, with PHP, with any language. But if we want to write a simple website, I can only do it with JavaScript, right? So WebAssembly comes to change that. Also today, WebAssembly needs JavaScript to work. So what exactly is WebAssembly? So WebAssembly is an open standard that allows the execution of binary code on the web, and obviously a code compiled against a language interpreted like JavaScript, there is a big difference in performance. A little bit longer description, it is a binary format. It allows us to be compiled from different programming languages. I think that is one of the WebAssembly greatest things, okay? So how does it work inside? So actually, when we compile, when we have a WebAssembly module, what we have is a kind of stack machine. It works with an instruction system, and this is used for mathematical operation, flow control, etc. And one of the curious things about WebAssembly is there are only 4 types. It only has integer and decimal, 32 and 64 bits, and any other different type, for example, booleans, are represented using any of these 4 types. So also WebAssembly has 2 formats, the binary format, which is one that we upload to the web, and then it has a text format. So now let's see what is the text format. As you can see, it has a really interesting aspect. The basic container module of WebAssembly, or its minimum unit, are the modules. So we can see the WebAssembly module in the same way that we see the MScript module in JavaScript. Therefore, a module has functions that can be exported. Here we have a WebAssembly module, and as you can see, it has multiply function, where it multiplies 2 numbers, and at the end, as you can see, it exports that multiplication. This is a simple example on what a module represents using text format in WebAssembly. So now, let's see how to use that function. So here, what we are going to see is how to import that WebAssembly module. JavaScript has an API to integrate WebAssembly. As we have said before, WebAssembly needs JavaScript to work. So once we have the compiled WebAssembly module, the first thing that we do is load the main WAS file, okay, which is where WebAssembly binary is, okay. Then there are several ways to get the instance, because the API has been changing and there are several examples, but I have chosen the instance streaming method, and as you can see here, it receives the promise of the request from the binary file. Then the browser is going to compile the WebAssembly module, and from there we will have access to the instance. And then through the instance and the export property, we can already access to the multiply function that we have done in WebAssembly. Now, if we compare the WebAssembly function against the same function in JavaScript, we will see more or less that WebAssembly function is 90% faster than JavaScript function. And in the end, we are only multiplying 2 numbers. We are not doing anything complex, okay? Also, there are cases on WebAssembly up to 11,000% faster. That's why we talk about the future of the web. It is also true that there are cases in which WebAssembly can be 20% slower than JavaScript. For example, with a very small arrays, this can happen, but these are exceptions. The normal thing is that the performance of WebAssembly is much better than JavaScript. Okay, so far. We have seen a little Rust. We have also seen WebAssembly. What we have left to see is how is WebAssembly with Rust. There are a couple. So Rust and WebAssembly are two technologies that work very well together. We have seen that we can write WebAssembly with any programming language, but Rust is being preferred due to the amount of documentation that we have. There are also some metrics that show it to us. I would like to show you some Stack Overflow metrics. So as you can see, both WebAssembly and Rust are in the top 10 of the most loved languages and the best payment. This is the last year, okay? So I think this is not a coincidence, and this is why. I think it is because there is a vast ecosystem of libraries, packages, and as you know, in the world Rust, crates, which is greatly simplified the development of WebAssembly with Rust, okay? Sorry. Here we have some of the most important. We have WasWinger, which allow us the interaction between Rust and WebAssembly and vice versa. Then we have WebSys. WebSys basically allow us to have access to different APIs, such as DOM, WebGL, console. Then we have JSys. It allows us to use global JavaScript objects, such as object, window, date. And then we have Webpack. It's related to the NPM environment. We use it to publish or build our Rust code, okay? So before showing you a bit of code, I would like to show you a little bit of the level of integration that exists between the two, okay? So here we can see the level of integration that Rust has in the JavaScript ecosystem, and it's surely greater than we think, okay? As you can see, we can use Parcel, which I recommended. After having worked a few years configuring Webpack, it's really simple to use it. We don't have to do nothing. By default, Parcel has Rust support. I will show you in the example. So also you can use Parcel, Webpack. You only have to add a loader, but it's the same. So with that I'm saying, we're going to be able to insert Rust code in our JavaScript application. Now my idea is show you a small example of what I did so we can see how this works, okay? So let's open. Okay, so let me open the Visual Code. Can you see my screen? My Visual Code?
Yeah, perfect.
Okay.
Yeah.
So basically,
Nico, if you can press Command++ or something like to just have a little bit bigger the font. Thanks. Yeah. That's it.
But let me. Okay, now I think it's better. Okay, so basically this is my structure. It's really simple. In one hand, we have this folder, call it crate, and we will have here our Rust module, okay? And this folder, JS, we will have our website. So basically, let me, before that, install the dependencies, because it's taking some time. Now, basically in this example, what we want to do, the idea of this example is to show an alert when we click on a button, okay? It's going to be a really simple example. So let's do it using Rust, okay? So basically the first thing that we have to do is importing our crate that we are going to use. This is WasWinger, okay? Sorry. Okay, then we have to use that WasWinger as a global. In order to do that, you have to declare that. So using prelude, okay. Okay, and then what we have to do first is use a tag. Let me how to use the tag. So basically, we have to use WebSwinger. We're using this tag in order to export a function from Rust to JavaScript. Okay. So basically, what we have to do now is import the alert from the window object. Okay. So basically, it's a function, call it alert, and this alert is going to receive a string. Okay. So and then the only thing that we have to do, let me copy this one. And then we have to create a public function, call it start, for example. It's going to receive a string. Okay, and execute other function with this one. Okay, so basically this is our example. We are using WebSwinger as a crate. Then we are saying that we want to use WebSwinger as a global variable, and then we can use this in order to export that function to our text format in WebAssembly. Okay, so now let me start the project. Once we start the project, what we are doing is building our Rust code. Okay, so and we are creating our WebAssembly package. Okay. Okay. Let me explain you a bit what I did in the website. So basically, it's really simple. We have a button, and we have the main.js. That what we are doing in the main.js, basically, we are importing the start function from our Rust file. Why from there? As I said before, we are using Parcel and a plugin called WebSwinger. We shouldn't worry about creating a WebAssembly instance and retrieve that function from there, because Parcel will do it for us. Okay. So basically, after that, what we are doing is adding a click event to our button and call it the start function coming from our Rust code. Okay. Sorry, I forgot it. Talking about the cargo. Cargo is the package manager of Rust. It's work similar to the package JSON. Okay. As you can see here, we are. Let me. So basically, what we have to do here is declare all the dependencies that we want to use in our Rust code. So as you can see here, I'm not using this one, but just I for explain to you. This is the if-else statements. Okay, if we want to use if-else, we have to include that dependencies, and then we are including also WebSwinger. It provides it allows us the interaction between JavaScript and Rust, and this one is really helpful for us because if we have some problems in the future, we will see that error in our console error in our DevTool. Okay, and this one is about the binary code of Rust. Okay, it's just some configuration, and then we're using WebSys. Okay, so we have some JavaScript object, window object. Okay. Okay, as you can see, the build is done, and now, as you can see here, we have the package folder inside our crate. So what we have here, it's our WebAssembly code. Okay, so as you can see here, we have. Let me move it. We have our binary code. Okay, and also we have our text format. Okay, with the logic that we wrote in our Rust code. Okay, and also WebAssembly has TypeScript support, and as you can see, we have the same logic right in TypeScript. So, Okay, so now let's see if it is working. Okay, as you can see, it's working. And if we want to change here, we want to change the text, we can do it. Oh, yes. After we save, we are building again. Okay, so so hello, chicas. Okay, so another thing that I want to share with you is how to create a Rust module. Okay, in order to do that, we have to be familiar with cargo. I mean, before work with Rust, we have to install it globally. Okay, when we install Rust, we are also installing cargo. That is his package manager. Okay, so if we want to create this folder, this module, okay, we have to use cargo. So cargo new name of the package. For example, Lenny or Lenny. Okay. So as you can see here, we have a new folder with the same structure that we have in our crate with the cargo, and we have to add the dependencies and also our Rust file. Okay. So I think that's it from my side. I hope you enjoyed. I don't know if you have any question.
Yes. Talk.
Yeah, I have one. What would you say is the best case for use of WebAssembly and Rust?
Sorry?
Or another code?
I couldn't got it. Sorry. Can you repeat the question?
Hello? Yeah? Can you hear me?
Yeah, I can hear you. Yeah.
Okay. Yeah. What would you say is the best case for WebAssembly, or what? Yeah. Where would you use it?
Nico, I don't know if you went away from the mic, but we are not hearing you now.
No, but actually, I didn't get it. The question, you know.
Okay. He's asking.
About, yeah.
He's asking about what do you think are the best use cases for this technology for using Rust through WebAssembly?
I mean, I was reading some documentation about WebAssembly, and I think WebAssembly is putting focus right now in some video games, you know, some video games when we have a lot of mathematical operation, you know, and probably doing in with JavaScript.
Sorry, Nico, like, could you check your microphone? Because like it was working very well till now, but I don't know if you...
Now it's working well?
No.
Okay.
Yeah, now it's
basically,
better.
the people try to put focus on WebAssembly, and in most cases, on the people are using WebAssembly are in the video games, okay, because they need a lot of mathematical operation, and the performance has to be improving all the time, okay. And also, I have my brother, for example, I was talking to Mati. My brother is using WebAssembly. He's working in Barcelona for Massimo Dutti, okay, and he's doing a showroom, you know, and he's migrating all the API logic to show the showroom, you know, to WebAssembly, just to performance things, okay. I don't know if that's the thing.
Okay. Yeah.
One thing there to complement that answer. For example, like in the context of Lenny Labs, we do like tons of visualizations. Like for example, in PayPal, they are doing like very heavy visualizations, and some of that visualization, not right now, but later it can be that like it is a lot better to be able to do it in the client instead of doing it in the server, because if you are doing it in the client, you can play with the variables and like have real-time feedback to change the visualization. And there are some like things that you cannot do right now in JavaScript because you cannot get that real time. And once you get a tool like Rust or like C++ through WebAssembly, in the pipeline, you like the horizons of like the things that you can do, like really open up. So even for our context, I see that, I don't know if this year, but we may use it.
Absolutely.
What other questions do we have for Nico?
Nico, I have a quick one. I see that you can import window object, document object as a dependency of Rust. Does it mean that we have full access to the DOM in the web page?
Yeah, actually we can do it. Actually, if you last week I was reading some frameworks about. I mean, there are some open source project that they are using Rust like a UI library, you know, and they are using everything on DOM using Rust. So as you can imagine, you can do everything. The only thing that there is a bottleneck right now is the styles, you know, when they are using.
I can barely hear you. The bottom thing?
Sorry? You can hear me, Mark? Yeah. Well, my micro is fucked up. Sorry, what I'm saying is there are some UI components made by Rust right now. So as you can imagine, they can access to everything in DOM. Okay.
And do you know if there is any improvement in the DOM manipulation part? I mean, it's obvious that any calculation is faster, but I don't know if the interaction with the DOM is faster also.
I don't know about the DOM, you know, but if you think about performance, and as you can imagine the performance like a pile, you know, and you have different pieces, one of the things, the best thing that you have using Rust is we don't have garbage collector, and also we already have the code compile, okay? So in terms of performance, I think could be better if you think about a pile, you know, because we have less pieces than the other one. Okay?
Yeah, of course. I was curious if the manipulation itself was optimized in some way, but that's fine.
Any other question for Nico?
No, from my side, no.
Sorry? Okay. Nico, like if somebody wants to get like their hands like dirty, like and create an example and everything, like do you recommend like Parcel? Do you have any maybe tutorials to share?
Yeah, actually I can do it. I mean, Parcel, it's really nice. As you can see, we only use Parcel. This is Parcel. This is a sling of Parcel. And this is the plugin that I'm using, okay? In terms of importing directly the Rust code instead of get the instance or WebAssembly, you know? So, and also if you use Parcel, we don't have to configure nothing. As I said before, it's zero configuration, okay? This is up to you, okay? If you are used to use Webpack, you can use it, but I really recommend Parcel in order to work Rust with JavaScript, okay?
Nice, nice. I think we don't have any like Rust or WebAssembly, but like a channel, but we can discuss more maybe in the front end channel or something like that.
That's a good plan.
So thanks a lot, Nico, and thanks everybody, and see you again next week.
Okay.
Bye bye.
Nico, good talk.
Okay.
Yeah,
Bye
great
bye.
talk.
Thanks, Nico.